Hello everyone, we're Project Group 8 presenting the project. My name is Mustafa and I will provide the overview and go through schema design. Starting from the dataset, our project DBLP dataset is a multi-gigabyte XML file with around 8.4 million publication records. The challenge isn't just the file size itself, it's mainly the structure. So before we could query anything, we had to turn that raw structure into a clean rational design. Our workflow was end-to-end. We designed the schema, presented the XML into CVS files, loaded them into PostgreSQL, and then ran the queries and indexing analysis. I'll start with an Excel validation because this is where the schema design actually got shaped. At a first step, I used Excel to check how full each column was across the 7 CVS files. I grouped the results from perfect at 100% down to unusable at 0%. This provided us with the which columns were worth keeping and shaped the schema that followed. So moving on to the schema design, at the center of the model, there are two main entities, the author and the publication, linked together with authored relationship. Publication is then specified into 7 subtypes: the article, book, introduction, and in proceedings, PhD thesis, and master thesis. Each subtype inherits the publication ID as a primary key and also a foreign key to publication. Moving on to the relational schema diagram to highlight the important relationships. So two relationships matter the most for the queries. First is the in proceeding to proceeding through the cross-ref. This links each conference paper to the proceeding volume it belongs to. Second is the in collection to book. This keeps the links between book chapter and its parent book together with the authored. These are the relationships that the queries rely on. So that completes the schema side. We validated the set of attributes, developed a clean relational design, and illustrated the two cross-ref relationships that query relays on. Moving on next to Christy for data acquisition and parsing.
Thank you, Mustafa. Hi, my name is Christy Maria, and I will be talking about the data acquisition, preprocessing, and parsing done in this project. The data is taken from dblp.org, where from the XML download page, two files were downloaded: dblp.xml.gz, which is a full data set at approximately 4 gigabytes after decompression, with 8.4 million publication data, and dblp.dtd, which defines the XML structure and is required by the parser at runtime. This is what the raw XML file looks like, which is a single root element called dblp, and inside it are millions of publication records, each typed as article, in proceedings, book, and so on. Each record carries a unique key attribute and child tags for fields like title, year, author, and book title. This is the Python parsing script. At the top, the 7 valid publication types are defined along with the specific fields to extract for each one, keeping only what is needed for their SQL queries. The parser works by extending Python's xml.sax content handler class and overriding 3 callback methods. Start element fires when an opening tag is hit and captures the publication key. Characters accumulate the text content into a buffer. And end element does the main work, saving field values, writing rows to disk, and handling the author deduplication. Rather than holding all records in memory, each publication row is written immediately to a temporary file as soon as its closing tag is encountered. Once the entire file has been parsed, the finalization step prepends the correct headers and copies to each temporary file into the final CSV output. The parser produces 10 CSV files: author, authored, publication, and one for each of the 7 publication types. Publication.csv contains the core identity columns such as the publication key, type, title, and year, shared across all the record types. In proceedings contains the book title column, which holds the conference name, and the cross-ref column, which links each paperback to its parent proceedings record. These 2 columns are critical for several of the SQL queries. I will now hand over the time to Shakthi for discussing the querying and optimization.
Hi, my name is Shakthi. Today, I'll be presenting our data system project with a focus on analyzing publication data using SQL queries. To begin with, the database was structured using multiple relational tables such as author, publication, and authored, along with subtype tables like article, in proceedings, book, and thesis table. The publication table acts as the main parent table, while the other tables store more specific details for each publication type. The author table is used to link authors and publications representing a many-to-many relationship. After creating the tables, the dataset was imported into each table using the import-export feature, ensuring all columns were mapped correctly and the data was loaded successfully. Now, moving on to the query section. Question 1. The first question is to find the number of publications for each type between 2016 and 2025. The query filters the data based on the year range and groups it by publication type and counts the number of records. The output shows the total number of publications for each type, helping compare which type is most common. Now, moving on to question 2. The question 2 is to find conferences that published more than 1000 papers in a single year. The query joins conference papers with the preceding tables and groups them by conference and year and counts the number of papers. It then filters those graded by 1000. The output shows conferences with very high publication count in a year, including large or popular conferences. Now, moving on to question 3. So what does the question 3 says? The question 3 is to calculate the number of conference publications for every 10-year period starting from 1976. The query creates decade ranges and counts how many publications falls within each range. The output shows how public volume has changed across decades, highlighting growth over time. Now, moving on to question 4. The fourth question is to find the most collaborative author in data-related venues. The query filters authors who published in venues containing the word data, then uses a self-join to find co-authors and counts distinct collaborators. For question 4, this query is designed to analyze relationships with the dataset by linking multiple tables together. I use joins between the publication and author tables to understand how authors are connected through their publications. I also applied filters to focus only on relevant data, which helps improve the accuracy of the table. Since the dataset is quite large and the query involves multiple conditions, it might take a bit longer to run. However, this allows us to extract more meaningful insights once the query finishes the executing. So, this output will show the final results that can be used for further analysis. Since this joins multiple tables, it requires quite some amount of time to compute the relation. So, output 4 shows the author with the highest number of collaborators. Moving on to question 5. The fifth question is to find the top 10 authors with the most publications in data-related venues from 2021 to 2025. The query filters recent publications, combines conference and journal data, groups by author, and counts total publication. The output shows the most active authors in the data-related field in recent years. On to question 6. The sixth question is to list conferences held in June with more than 200 publications. The query filters conferences with June in the title, joins with the conference papers and counts the number of publications, then filters about 200. The output shows major conferences held in June with high publication volume. For question 7a, the seventh question part A is to find authors who published at least one paper every year from 1996 to 2025 and whose name starts with H. The query checks across all years and ensures they appear in all 30 columns and filters names starting with H. Question B, the seventh question B is to find authors with the earliest publication record. The output shows the earliest contributors in dataset, which finds the earliest year and retrieves authors who published in that year. Now moving on to question 8. The eighth question is to design a custom join query. The query finds authors who have consistently published in the same conference across multiple years by grouping and filtering based on years and number of papers. In conclusion, these queries help analyze publication trends and conference activity and author collaboration using SQL. Thank you.
Hi, I'm Xingjia Yang, and I will introduce the experiment of 4 sides DB, half sides, quarter sides, and with index. Then, before each query, I will run this bash code, since that it will help us to clear the cache of the system, cache of the first-degree CQs. Then, how to cut half? I will to do a new schedule mask, and then I will half select the pub ID from the publications, and then according to the pub ID, I will to cut half of all of the tables. Then how to cut quarterlies? I will do it again on the half DB. Then for the indexed query, I will firstly create an indexed and then refresh the tables, and then I will run this bash code. And when I open this bash code, then I will run the analysis. I mean the queries with the explain, and it will tell us the precise execution times. Then after that, I will drop the indexed, leave the environment clear, since that it will not influence the next queries. And then that's all.